Hey everyone, so today we're going to be working on solving inequalities. So the first thing we're going to work on is just kind of our general set notation and interval notation. So we've talked about this briefly. This is when we're writing it with parentheses and brackets. Okay, so let's just try a couple of these out. So first of all, you've seen these before. X is less than 3, less than or equal to 3, greater than 3, greater than or equal to 3, and then when it's written like this, that means X is in between 4 and 10. Okay, and that equal sign, remember, gives us a closed circle on our graph. Or if you're graphing the line, it would be a solid line versus a dashed line. So X is less than 3. Okay, that means we draw in 3. We have an open circle. And you can either do something like this and kind of say less than 3. I usually just kind of scribble. Go this way. You could also do a highlighter, something nicer. But the biggest thing is you need an open circle and less than or equal to 3. Okay, you would do a closed circle at 3. And same thing, either an arrow or something very obvious saying you're going forever in the other direction. It's things that are less than 3. It also is kind of pointing the right way. And let's actually continue graphing. I want to graph all 4 of these, and then we'll talk about what is interval notation. Super important and notation that we're going to use actually throughout calculus and beyond. So definitely something you want to feel okay about. So X is greater than 3. Okay, we're at 3. It's an open circle because it's not equal to. And we are going to greater than 3, 4, 5, 6, 7, 100, 1000. And greater than or equal to 3. We are going towards the right, but we are including 3 in this answer. Okay, so in this answer, we would say 3.0001 is included, 3.2, 4, 5, 6, 7. In this answer, 3 itself is included. Okay, so here's how we're going to write this. All right, we use interval notation to signify an easier way to write this than inequalities. We can kind of expand a little bit further. So what numbers, you want to go lowest to highest. All right, so the lowest number here would be negative infinity, right? And then we go all the way up to 3. We don't include 3, so we're going to do a parenthesis. Infinity and negative infinity always have parentheses, okay? And then any open circles would be parentheses. So let's take a look at the next one. How would that change? Well, we go from negative infinity all the way up to 3, but we put a bracket. Bracket means it is included, all right? It is included, and we also want to take into account that we're going low to high. So you might want to read it like 3 to negative infinity, but negative infinity is the smallest number, right, possible number. So we are going to be writing it in negative infinity to 3. All right, next one, if we're scanning left to right, well, 3 is the smallest number, not included, so parentheses, and we go up to positive infinity, parentheses. So again, infinity and negative infinity are always parentheses. We never want to put brackets since we can't actually graph that point. It's just a hypothetical biggest and smallest number we can imagine. Okay, and then 3 to infinity, the next one, same thing, except we include 3 and go to infinity. All right, the last one, like I said, X is greater than 4 and less than or equal to 10. When it's written this way, it's pretty easy to write in interval notation. You're going to say 4 is the smallest, not included because there's no equal sign. Up to 10 is the greatest, and 10 would have a bracket because it is included. So 4 up to 10, closed circle. And again, 10 would be closed because it is less than or equal to 10. All right, so that is your set notation, interval notation. We're going to be using that for all of our answers from now on. So I do not want these as answers. I want interval notation as your answers. All right, so we're just going to try 2 solving inequality problems that are kind of Algebra 1-ish, kind of throwbacks. Don't forget, when you multiply or divide by a negative, you have to flip the inequality sign. All right, so let's start off with this first one here. You'll notice it's kind of like, I don't know. I mean, it's kind of a fraction times a fraction. I would just multiply both sides by negative 8. And notice I'm multiplying by a negative. These cancel. I have 2x minus 5 is less than negative 8 times 1 minus x. Again, it flipped because I multiplied by a negative number. 2x minus 5 is less than negative 8 plus 8x. Okay, and we just solve here. Let's see. I'm going to subtract 8x, add 5. I get negative 6x is less than negative 3. All right, divide by negative 6. I'm dividing by a negative. So guess what? We flip again. X is greater than positive 1/2. So again, it flipped because I divided by a negative number. Some people get confused and they think it's whenever we divide. It's specifically when we multiply or divide by a negative. All right, so final answer, x is greater than 1/2. Write in interval notation and graph the solution. Well, it goes from 1/2 up to infinity. And if you're not comfortable there yet, maybe graph it first and say, all right, we're at 1/2. It's an open circle, and it's things that are greater than 1/2. All right, so those would be your two pieces of your final answer. Okay, I wanted to try out one that's kind of in that compound inequality format, which means there's two signs. This is actually something you can keep the same and just make sure if you subtract 5 from the middle, we have to do it to both sides of the inequality here. So I get negative 1 is greater than negative 6, which is greater than or equal to negative 6. Your last step here, you want to get x by itself. Divide by negative. You'll see I'm bringing this up a lot. Now I have positive 1/6 is less than, flip the sign. Okay, and I'm going to put a preemptive dot because I'm going to get x is less than or equal to 1. Again, flipping because I'm dividing by a negative. All right, it's between 1/6 and 1 bracket. Or you could graph first. Open circle at 1/6, close circle at 1, and that is the ending there. So when it says interval notation, I mean this. When it says graph it, I mean that. All right, we're going to save the third one for class. I want to try some that are kind of this Algebra 2 version. And what I mean by that is we're going to step into ones that are inequalities. All right, inequalities, I meant to say quadratics. And we're doing all inequalities. Inequalities with quadratics or cubics or more than one x value. So you'll notice here we just had x to the first power, and that was kind of it. So what happens when we get r squared, x squared, y to the third, whatever it may be? Okay, we're gonna, the directions are right here. So we're gonna get 0 onto one side and factor. We're gonna find the solutions, set up some testing intervals here. So let me show you what I mean. So first direction was get it set to 0. I'm gonna factor, that's the next direction. And you want to find the critical values. Critical values means when is this equal to 0? At -4 and +3. That's because if I set each of these parentheses to 0, those are the answers I would get. Kind of like if you were solving for factoring. All right, I draw my number line. I put -4 and 3 on it because those are my critical values, okay? And then now I'm going to basically test out, okay? We're going to be testing out r plus 4 times r minus 3 right here. Okay, this piece, let's see, don't want to do anything too dark. This right here factored, I think that's the easiest thing to test. We're going to be testing out when I plug in a random value, do I get back a negative or a positive? All right, so what if I plug in something below -4? Okay, so if I plugged in, let's say, -6, I would get -6 plus 4 times -6 minus 3, which is a negative number, times a negative number, which is a positive. So notice I didn't actually calculate it, all right? And I can actually do this in my head. I don't even have to write down plugging in -6. All I really want to know is when I plug in negative, I could plug in -100. -100 plus 4 is negative. -100 minus 3 is negative. Negative times a negative is a positive. So this entire interval is going to give me positive values. All right, let's try, and you want to do each interval. How about between -4 and 3? Well, what's a number in between? I would pick 0. What's 0 plus 4 times 0 minus 3? Again, you don't have to write that. That would be a positive times a negative, which is a negative. So this entire interval here is negative. Any number you plug in between -4 and 3. All right, and last but not least, something greater than 3. Think of a number in your head greater than 3. Okay, I thought of 10. 10 plus 4 times 10 minus 3. Positive times a positive is a positive. Okay, so again, what we did, we got it set to 0, we factored, we found the critical values, we set up a number line and figured out what intervals are negative or positive. And the last step here is actually answering, okay? And you're answering by looking at this. We want to know when it is greater than or equal to 0. What does that mean? When is this positive? When is this equation positive? Well, it's positive from -4. Now notice this is greater than or equal to, closed circles. -4 to negative infinity, or negative infinity to -4. And 3 to infinity. So again, all I looked at, guys, was right here. Those plus signs. That tells me it could be one interval, it could be 3 intervals, it could be 2 intervals. That tells me where this equation is positive. So if I were to write this out, we know how to write this. This is negative infinity up to -4. If you, oh, sorry, that should be a bracket because it's a closed circle. If you have more than one interval filled in, we're going to use this symbol called a union. Okay, so think of it like united with, union, bracket 3 to infinity. Okay, if you plug in any number between negative infinity to -4 or 3 to infinity, I would get back a positive for this equation. All right, so that's how we do this. The reason I want to get it set to 0 is I don't have anything special for greater than 12, right? But greater than 0 is positive, less than 0 is negative. All right, and that's our final answer here. If it's set to graph, here's our graph, already graphed, and that's interval notation. So let's try a couple more here, all right, see how we're feeling. So next one up is already factored for us. Remember, the first step is get it set to 0. We did it. The next step is factor it. It's done. Your next step is when is this equal to 0? So that would be y equals -2, +7, and -12. So notice again, I'm setting each parenthesis to 0. I create a number line with those values from least to greatest, -12, -2, and 7. All right, again, I'm plugging into y plus 2, y minus 7, and y plus 12. I'm not going to write anything down this time. Let's just try to do it in our heads, okay? So, what's something less than -12? I'm going to pick -100. You can literally pick any number below -12. This would give me a negative. If I plug in -100 here, negative. If I plug in -100 here, negative. Negative times a negative times a negative is a negative. All right. How about something between -12 and -2? I'm going to pick -3. All right. So -3. If I plugged it in, this would get me a negative. This would get me a negative. That says plus 12. So I currently have negative times a negative. If I plug in -3 here, positive. Negative times a negative times a positive is a positive. Okay. I'll erase my little underlining. What about if I plug in something between -2 and 7? How about 0? Okay. If I plug in 0, I would get a positive. If I plug in 0 here, I would get a negative. If I plug in 0 here, I get a positive. Positive times negative times positive is negative. All right. How about 7 to infinity? Okay, 7 to infinity. Well, I could plug in like 100, positive 100, positive, 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 if I plug in 100. 3 positives gives me a positive. All right, let's see what we're looking for here. We want to know when is it greater than or equal to 0, aka when is it positive. It's also closed circles, if you want to write yourself a note. So closed circle, closed circle, closed circle. Where is it positive? Between -12 and -2, and from 7 to infinity. So let's write that down. -12 to -2, bracket, union, 7 to infinity. Parenthesis. Infinities always are parentheses. Okay, so see how you feel about that. We're going to try one more. You might be wondering, do they always alternate? Here I had plus, minus, plus. Here I had negative, plus, negative, plus. Do they always alternate? My answer is no. And we're going to show you an example 3. So we'll just do one more example here, guys. Let's finish it off with example 3. We'll save the other 2 for class. Okay, so let's think the first step. For starting this off, get it set to 0. Done. The second step is factor. All right, well, it has a GCF of x squared. And then we can factor this as x minus 6, x minus 8. All right, so get it in that factored form. And then we want to decide, you're looking at all three of these. When is it equal to 0? Okay, that would be at x equals 0, at positive 6, and at positive 8. Okay, this x squared right here, that gives me when is x squared equal to 0? At x equals 0. That's where that's coming from. All right, so you've got your three values. It could be 2, it could be 4, it could be, I don't know, I guess it could be 1. We've got 0, 6, and 8. Notice I'm going to have, if you look ahead, you're going to have open circles. So maybe I'll just even draw that in now. Open circles for everybody. Okay, and then the next step is you want to test out your intervals. So you're using this right here, x squared times x minus 6 times x minus 8. I highly recommend using the factored form. Technically, you can use this, but I don't think you have any interest in bringing something to the fourth, something to the third. This is a lot easier. So use that factored form with something less than 0. How about negative 10? Okay, if you plug in negative 10 here, this is always positive. For every number we plug in, right, something squared is positive. So if I plug in negative 10, I would get positive. If I plug in negative 10 here, I'd get negative. If I plug in negative 10 minus 8, I would get a negative. Positive times a negative is a positive. Okay, how about if I plug in 0 to 6, how about 4? Positive 4. So I would get a positive always. 4 minus 6 is a negative. 4 minus 8 is a negative. Positive times a negative is a positive again. Interesting. All right, from 6 to 8, how about 7? All right, if I plug in 7 here, I'd get a positive always, times a positive, times a negative. Positive times a negative is a negative. All right, and then last but not least, 8 to infinity. 8 to infinity would be, let's pick 10. So positive times a positive is a positive. All right, now let's think what we need here, people. If this said less than or equal to, we'd be looking for negatives. It says greater than. Greater than to me means positive. Okay, so I'm looking for any positive intervals. Well, I have a positive interval from negative infinity to 0. I also have one from 0 to 6, and I also have one from 8 to infinity. Okay, I want a side note here. If this was a filled in circle, okay, I could just say negative infinity to 6. But because we want to skip 0, all right, and why do we want to skip 0? Well, if I plugged in 0 here, guys, you would get 0 minus 0 plus 0 is greater than 0. Is that true? Is 0 greater than 0? No, that's not true. Okay, that 0 is greater than or equal to 0, but when it's an open circle, we want to skip over it. So final answer here, negative infinity to 0, parenthesis, not included, open circle, union, 0 to 6, union, 8 to infinity. So everything except for 6 to 8, and then not including our critical values since it was open circles. All right. And that's what we're going to do for now. Example 4 and 5, we're going to try in class. But make sure you understand that process of plugging in and getting those positives and negatives. I think that's usually where people are thrown off. So feel free to rewind if you need to. And thank you so much for watching.